And welcome back. We are now in 2.2 of Chapter 2. Remember, Chapter 2 is about matter and change. We're talking about the different forms that matter can take and the changes that matter can undergo. And in this section, we're dealing specifically with mixtures. We touched on mixtures in the last section, and we want to get a little more detail on what these mixtures are. So, first of all, a little definition here. A mixture is a physical blend of two or more, I'll just put 2 plus, substances or components. All right. Some different mixtures that we've already talked about would be milk. Milk can be, again, it's a blend of water and fats and lactic acid and some other components. And not all milk is the same, whether it's goat's milk or cow's milk, or any other type of milk for that matter. And even if we're dealing with cow's milk, it could be 2% or 1% or half or skim or whole or whatever the case is, but it's all milk. All right, and made up of pretty much the same components. Wines are also mixtures. They contain different amounts of sugars and different amounts of alcohol with them, depending on the grapes and how long they've aged and whatnot. Okay, so those are two common examples of mixtures. Many of you have made Kool-Aid. Kool-Aid would also be a mixture of water and sugar and the flavorings and the colorings. And not all Kool-Aid is the same. Some people put more sugar than others. So I think you get the point. It's a blend of two or more substances. But you can also separate them. And we'll be talking about that. But you know, in terms of milk, if you've ever left milk out, milk will separate itself. Kool-Aid won't necessarily separate itself unless the water evaporates out, but milk will. All right. Now, there are different types of mixtures that we can talk about. We're just going to scroll down a little bit here. First of all, you have what are called heterogeneous mixtures. And secondly, you have homogeneous mixtures. Now, first of all, let's take a look at these prefixes. It's a good idea in science to learn prefixes because there are a lot of different terms that sometimes you only see once or twice, but yet if you know what prefixes mean, you can figure them out. The prefix homo means same, while the prefix hetero means different. So if you have a heterogeneous mixture is one that has different phases. As opposed to a homogeneous mixture is going to have the same or one phase. Okay? Now, before we even get into the example here, let's talk a little bit about a phase and then we'll come back up. A phase is any part of the sample with a uniform composition. Any part of a sample with, just a W with a slash is with, a uniform composition. Sometimes I just look at the way I describe a phase is it's a distinct area that you can visually detect. Okay, so knowing that, let's look at these pictures to the right, and then we'll give you some examples. Olive oil is a mixture. It's a mixture of a bunch of different types of oils. But yet when you look at olive oil all around in here, you can only see one phase. It looks like one entity. The same thing with vinegar. Vinegar is a blend of water and what's called acetic acid. All right, but as you look in vinegar, it looks like one thing. Olive oil looks like one thing. Now, if you put olive oil and vinegar together, this is also a mixture, but yet you have two areas. One area there, two areas, the second area there. So it has two phases. That's what we mean by phases. If you can look at it and see a distinct area, then that's going to be considered a phase. Now, an example of heterogeneous mixture with different phases. Pulpy orange juice. I'm just going to write OJ, pulpy OJ, because when you look at it, you can actually see the chunks floating around. Dirty water or sandy water. For example, if you scoop up some water from Lake Erie, you're going to have sand and dirt and different things floating around in there, and you can actually see those things floating around. As opposed to a homogeneous mixture, which has the same phase, tap water. When you get water from the tap, hopefully it's just clear. If you have stuff in there, well, you might need to check something. But tap water, it has minerals, it has a bunch of stuff in there, but yet you can't see. We've already mentioned Kool-Aid. As a mixture, it would be considered a homogeneous mixture because as you look through the Kool-Aid, it only looks like one thing. Apple juice. Hopefully, anyway. Apple juice looks like one entity as opposed to, going back up to a heterogeneous mixture, we'll say apple cider. If it's freshly squeezed. Now you can get, I'm sure you can actually get homogeneous apple cider, but oftentimes you're gonna, if you get it right at the cider mill, you might have like little chunks of apples floating around in there, very, very thin. But anyway, that if it's in there, it'd be considered a heterogeneous mixture. If it's not, it'd be considered a homogeneous mixture. Okay, so there's a brief introduction to mixtures. Now the deal with mixtures, it is a physical blend of two components. And we're a little bit out of room over here. I'm going to add to this definition that can be separated using physical properties. It can be separated using physical properties. And in the next podcast, we're going to talk about two different ways to separate mixtures.